Okay, in our last little quick one, we looked at speed versus velocity. And in that particular one, what we did is we had a person who traveled a path. It was a little odd. We're traveling it via the roads, and we went from our starting point to the party. And we talked about that the distance traveled was 12 kilometers. And we were given the time frame that this occurred. But for this discussion, we're not really worried about that time frame, other than that we had a change in time was equal to some value. But then we talked about that we had something that we looked at as the displacement. Okay, so this part here is the distance traveled because we had to do it in each individual segment. But this is our displacement. And the displacement only cares about where we started and where we stopped. So if I had this as a point 0, 0, and I have this as a point, we're going to go ahead and make it, let's make it 4 kilometers in the X direction, and we'll make it 3.5 kilometers in the Y direction. That's going to give us our displacement. Now the distance traveled does this meandering. We could have actually done some backtracking, or we could have done a U-turn. So this distance traveled doesn't necessarily relate to our displacement. And our displacement is a vector. And our vectors have direction and magnitude. And that magnitude is how long that vector is. Now, if I've been given the end coordinates of our system and the beginning of coordinates of our system, we can determine that displacement. So if I do that, we know that if this is our triangle here, we know that a squared plus b squared is equal to c squared. And we can also do that r is going to be my initial or my final point if I'm in the x direction minus my initial point, and we're going to use I as a unit vector in the x direction. Okay, so it has a magnitude of 1, and we can write it like that. Now I can do the same thing for my y direction. It's 3.5 minus 0 in the j, and j is my unit vector. I'm going to go ahead and make sure that the notes are clean, and that's a unit vector, and it's a unit vector in the y direction. So I end up with my vector r as 4i plus 3.5j. And you've probably seen this in algebra class. That's not anything that you haven't seen before. So the magnitude of r is going to be the square root of the 4 squared plus 3.5 squared. So we'll plug that into the calculator. I'm going to go ahead and do my square root. I'm going to have my 4 squared plus 3.5 squared. Close my parentheses. And this is going to give me a magnitude of 5.32 kilometers. And then I can use my trigonometry to give us the angle. So the tangent of my angle is going to be 3.5 divided by 4. And if I do that, that's 0.875. And then my angle is going to be the arctangent of my 0.875. And that is going to give me 4.8 41.2 degrees. So the displacement is 5.32 kilometers. Our direction is given by this angle, and that's 41.2 degrees. And this would be the distance as the crow flies versus the total distance traveled. So when I do average speed, that's total distance divided by the change in time, where average velocity is the displacement divided by the change in time. So one is a vector quantity and one is a different quantity than what we were talking about. So remember, displacement is a vector. We can find our vector components and we can find our angle